And now in this lecture I'll answer two questions. In the first question, we'll find out the length of this line 7a cubed equals to x. We have to find out the value of x. And in the second question, we'll find out the area of this quarter circle AOB. So let's start with the first question. In the drawing, we have semicircle APCB. In addition, we know that this is line segment QC. This equals to 6 units in its length. This is called CB. This equals to 5 units in its length. Those two arcs, that is to say arc PA and arc CB, they are equal to each other in their lengths. This is angle PQC. This equals to 90 degrees in its size. Again, our test is to find out the length of this line 7, short line 7a cubed. This equals to x. We have to find out the value of x. So, first of all, we can implement all 7 in our drawing. Why? Because in our drawing, we have peripheral ACB. This is peripheral ACB. Let's subtend on chord AB, that is the diameter of this semicircle. And according to all 7, any peripheral that subtends with the diameter of a circle or semicircle must be equal to 90 degrees in its size. So repeat quickly on all 7. According to all 7, if a peripheral angle subtends on the diameter of a circle or semicircle, then it is equal to 90 degrees in its size. In the drawing, we have a circle. This is peripheral ACB that subtends on chord AB, the diameter of this circle. Therefore, peripheral angle ACB must be equal to 90 degrees in its size, according to this rule, all 7. So according to all 7, any peripheral angle that subtends on the diameter of a circle or semicircle must be equal to 90 degrees in its size. So we can implement all 7 in our drawing. In our drawing, so as I mentioned before, this is peripheral angle ACB. This subtends on chord AB, that is the diameter of this semicircle. And therefore, peripheral angle ACB must be equal to 90 degrees in its size according to all 7. And AB, chord AB is the diameter of the semicircle. It is given us the question that chord PA equals to chord CB in its length. Actually, arc PA equals to arc CB in its length. This is arc PA and this is arc CB. They are equal to each other in their lengths according to what is given as the question. Arc PA equals to arc CB in its length. The rounded sign above PA and CB is the sign for arc. It means arc PA equals to arc CB in its length, according to what is given as the question. So here we can implement all 56. So repeat quickly on all 56. According to all 56, if two arcs are equal to each other in their lengths, then their corresponding chords must be also equal to each other in their lengths. In the drawing, we have a circle. This is arc AB. This is equals to arc CD in its length. Those two arcs are equal to each other in their lengths. And therefore, according to this rule, all 56, their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc is AB, and the corresponding chord of this arc is CD. And according to this rule, rule 56, code AB equals to code CD in its length. So we can implement rule 56 in our domain. Now at the moment, it is given us a question that code arc PA equals to arc CB in its length. We join points A and P together by straight line. By joining points A and P, we get chord PA. The corresponding chord of this arc is PA, and the corresponding chord of this arc is CB. According to rule 56, the corresponding chords of those two arcs are equal to each other. That is to say, again, the corresponding chords of those two arcs are equal to each other. That is to say, chord PA equals to chord CB in its length. Chord PA equals to chord CB in its length, according to rule 56. It's given us a question that chord CB equals to 5 units in its length. So we can write here that chord CB equals to 5 units in its length. And for this equation, chord PA equals to chord CB equals to 5. We will derive that chord PA must be also equal to 5 units in its length. So here, this is chord PA. It is also equal to 5 units in its length according to rule 56. In the next step, we will join points P and C together by a straight line. By joining points P and C, we get a triangle ACP. This is triangle ACP. Triangle ACP subtend on chord PA that is equals to 5 units in its length. Likewise, this is triangle CAB that subtend on chord CB that is also equals to 5 units in its length. And because of the fact that those two triangles subtend on equal chords, must be equal to each other in their sizes, according to rule 57. So this is triangle ACP. Triangle ACP is equal to this triangle CAB Why they are equal to each other? Because both of them subtend on equal chords. Equal to 5 units in itself. This is according to all 57. So those two peripherals are equal to each other in their sizes. So if we define the size of this peripheral PCA as alpha, then the size of this peripheral CAB must be also equal to alpha because they are equal to each other in their sizes according to all 57. In the next step, we will focus on this right triangle PQC. And again, we focus on this right green triangle PQC. The right green triangle PQC. This angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, in this lower right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this furthest angle must be equal to 90 degrees minus alpha, according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the green right triangle PQC is similar to this right lower triangle ABC according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So if we found out that all the figures of this green right triangle PQC are corresponding equal to all the figures of this right small triangle, right lower triangle ABC, and therefore those two right triangles are similar to each other according to angle similarity rule. So right now we should find out that this is the green right triangle PQC. And it's similar, this is the sign of similar, to the right lower triangle ABC. According to angle similarity rule. Again, I should find out that the right green triangle PQC is similar to the right lower triangle ABC according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC or side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC or side AC of this right lower triangle ABC. So PQ over CB equals to QC over AC. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of the green triangle or side CB of the right lower triangle ABC equals to side QC of the green triangle or side AC of the right lower triangle ABC. PQ is the missing side, so we will leave it as it is. Over CB, CB is 5, and it is equals to QC, QC is 6, according to this given equation, over AC, AC in total equals to X plus 6. So in total, we have found out that PQ over 5 equals to 6 over X plus 6. Again, PQ over 5 equals to 6 over X plus 6. Here we will multiply this equation by 5 and finally get that the missing side PQ is equal to 5 times 6 is 30, so in total this expression equals to 30 over x plus 6 units in its length. Again, we should find out that this is the missing side PQ. This is equals to 30 over x plus 6 units in its length. So written down, PQ equals to 30 over x plus 6 units in its length. It is given us a question that AC is the straight line. So if you focus on the upper side of the straight line AC at point Q, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have at the upper side of the straight line AC at point Q? We have this angle that is the right angle, plus this missing angle. In total the sum of those two areas must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. And therefore triangle APQ is a right triangle. So in the next step we will implement the Pythagoras theorem of this right triangle, triangle APQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Hereby PT is a abbreviation for Pythagoras theorem. So in this right small triangle APQ, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. If we again in this right triangle APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. AP is 5, therefore AP squared is 5 squared, that is 25. And it is equals to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared. Plus QA. QA is x, therefore QA squared is x squared. QA is the line segment that we are looking for in this question. So in total, we actually found out that (25) equals to 30 over x plus 6 squared plus x squared. So 25 equals to 30 over x plus 6 squared. 30 over x plus 6 squared equals to 30 squared, that is 900, over x plus 6 squared. Plus x squared. So 25 equals to 900 over x plus 6 squared plus x squared. Here we multiply x squared by x plus 6 squared, and then we will divide it by x plus 6 squared in order to have a common factor of this expression. So we have x squared times x plus 6 squared divided by x plus 6 squared. We multiplied it by x plus 6 squared, and then we divide it by x plus 6 squared, so we change nothing. It is allowable to multiply anything by 1. So in total, we found out that 25 equals to 900 plus x squared times x plus 6 square over x plus 6 square. Here we will multiply this equation by x plus 6 square. And we will get that 25 times x plus 6 square equals to, here x plus 6 square we get cancelled, and we left only with 900 plus x square times x plus 6 square. We open the brackets on both sides of this equation. We get, here we have 25 times x plus 6 square. X plus 6 square equals to x square plus 6 square, that is 36, plus 2 times x times 6, that is 12x. Equals, in the other side of the equation, we have 900 plus x square times x plus 6 square. So it is x square times x plus 6 square. X plus 6 square equals to x square plus 6 square, that is 36, plus 2 times x times 6, that is 12x. We open the brackets on both sides of this equation. This side of the equation, we have 25 times x squared, that is 25x squared, plus 25 times 36 is 900. Here we have 12x, of course. And 25 times 12x is 300x. The other side of this equation, we have 900 plus x squared plus 36 plus 12x. So we will open the brackets of this expression, and we will get that x squared times x squared is x to the power of 4. And we have x squared times 36 is 36x squared, plus x squared times 12x is 12x cubed. So here we have 900 on both sides of this equation, so 900 will get cancelled. After cancel 900, inside of the equation we left only with 25x squared plus 300x equals, on the other side of this equation we left with x to the power of 4 plus 12x cubed plus 36x squared. So here we subtract 25x squared from this equation. So here 25x squared will get cancelled, and we left only with 300x equals, in the other side of the equation we have x to the power of 4 plus 12x cubed, and 36x squared plus 25x squared is 11x squared. So here we will subtract 300x from this equation. So on this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So I copy this equation in a new page here. And we found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. And again, in total we found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we take out x as a common factor from those four expressions. So inside the brackets we left here with x cubed plus 12x squared plus 11x minus 300 equals to 0. This equation has two solutions. The first solution to this equation is x equals to 0. If x equals to 0, 0 times anything is 0. When the 0 equals to 0. The left side of the equation equals to the right side of the equation. Therefore, x equals to x is the first solution to this equation. The other solution to this equation is that this expression inside the brackets equals to 0, and 0 times x is 0. We get that 0 equals to 0. So the second solution to this equation is that x cubed plus 12x cubed plus 12x squared plus 11x minus 300 equals to 0. So the first solution to this equation is that x is equals to 0. But the problem is that x can never be equal to 0. Because of the fact that x is the length of this line segment AQ, so x as a length must be a positive number. So as you know, x is the length, and x as a length, it must be a positive number. 0 is definitely not a positive number, and therefore x can never be equal to 0. So we cancel this solution, and we left only with the second solution to this equation, that actually this expression equals to 0. So first of all, we check that if x equals to 3, if this equation is true for x equals to 3. So if x equals to 3, what is the value of this expression? Is this expression is true when x equals to 3? So we just have to substitute x by 3 and we find out if this expression is equation is true for x equals to 3. If x equals to 3, then x cubed is 3 cubed. 3 cubed is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9. 9 times 12 is 108. Plus 11x. X is 3, so 11x is 11 times 3, that is 33. Minus 300, it should be equal to 0. If x equals to 3, solve this equation. The sum of these numbers, those numbers must be equal to 0. But 27 plus 108 plus 33, in total it is 168 minus 300 is definitely not equals to 0. So if x equals to 3, is not a solution to this equation, because the right side of this expression, or the left side of this expression, is not equal to the left side, because 68 minus 300 is definitely not 0. So x equals to 3 doesn't solve this equation. In the next step, we'll check that whether if x equals to 4 solves this equation. So if x equals to 4, you just have to substitute x by 4. So x cubed is 4 cubed. That's actually 4 times 4 times 4, that is 64, plus 12x squared. X is 4, so x squared is 4 squared, and this is 16 times 12. 16 times 12 is 192, plus 11x. X is 4, so 11x is 4 times 11, that is 44, minus 300, it should be equal to 0. 44 plus 64 is 108, plus 192, minus 300, it should be equal to 0. 108 plus 192 is 300, and 300 minus 300 is indeed equals to 0. So if x equals to 4, solve this equation. So this equation is solved for x equals to 4. So we have this, so if this expression equals to 0, then this equation is true. So we have here x cubed plus 12x squared plus 11x minus 300 equals to 0. And again, found out actually that x cubed plus 12x squared plus 11x minus 300 equals to 0. This expression is identical to the following equation, to the following expression. This equals to x minus 4 times x squared plus 16x plus 75. So those two expressions are identical. Well, because if you just open the brackets of this expression, you get that those two expressions are identical. If you open the brackets of this expression, you find out that this expression in total equals to x cubed plus 12x squared plus 11x minus 300. So this expression equals to 0, and therefore the identical expression must be also equal to 0. So now it is very easy to solve this equation. Here we will have two solutions that are possible for this equation. The first solution to this equation is that x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. You get that the left side of the equation is equal to the right side of the equation. So the first solution to this equation is x minus 4 equals to 0. If x minus 4 equals to 0, we will add 4 to the equation and find that x equals to 4 units in itself. So the first solution to this question is that this is 970 cubed is equals to x and x equals to 4. That is the first solution to this question. But this equation has two solutions. Why? Because if the expression inside the brackets equals to 0, then 0 times x minus 4 is 0. And we get that 0 equals to 0. So the second solution to this equation is x squared plus 16x plus 75 equals to 0. But the problem is that maybe this quadratic equation has no solutions at all. So we must verify that this quadratic equation has at least one solution. So this is a quadratic equation, and the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. in this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. The expression inside the root is b squared minus 4 times a times c. The expression inside the root is defined as a determinant of this quadratic equation. And again, the determinant of this quadratic equation is b squared minus 4 times a times c. Actually, we have a rule that said that if a determinant of a quadratic equation is negative, then the quadratic equation has no solutions at all. Okay, if the determinant of a quadratic equation is negative, then the quadratic equation has no real solutions at all. Okay, so we must verify that the determinant of this our quadratic equation is not negative. Why? Because if it is negative, it means that this quadratic equation has no solutions at all. So, again, our quadratic equation is x squared plus 16x plus 75 equals to 0. This quadratic equation, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. And the determinant of this quadratic equation is b squared minus 4 times a times c. So we just have to put the number inside this determinant in order to verify that the determinant is not negative. B is 16, therefore b squared is 16 squared, that is 256. Minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is 75, so minus 4 times 75 is minus 300. So in total, if we found out that the determinant of this quadratic equation equals to 256 minus 300, that is definitely a negative number. Therefore, this quadratic equation has no solutions at all. That is to say, we don't have any number that can solve this quadratic equation. So because of the fact that this quadratic equation has no solution at all, it means that the second solution to this equation is incorrect solution. It has no solution at all. Actually, we can prove in another way that this quadratic equation is no solution at all. So our quadratic equation is so our quadratic equation is x squared plus 16x plus 75 equals to 0. So we will prove in the second way that this quadratic equation has no solutions at all. we just substitute 75 plus 64 plus 11. So this equation, this quadratic equation equals to x squared plus 16x, and 75 is 64 plus 11 equals to 0. This expression x squared plus 16x plus 64 equals to x plus 8 squared. If you open the brackets of this expression, you find out that x plus 8 squared equals to x squared plus 16x plus 64. And we have here also plus 11, in total it is equals to 0. Here we will subtract 11 from this equation, and finally get that x plus 8 squared equals to minus 11. Minus 11 is definitely a negative number, but x plus 8 squared is definitely a positive number. X plus 8 squared can never be equal to 0. Why? Because of the fact that x is one side of this right triangle APQ. The hypotenuse PA equals to 5, and therefore the hypotenuse of any right triangle is the longest chord, longest side of the right triangle. That is to say, AQ must be less than 5. AQ can never be equal to 8. Okay, so even if AQ equals to 8, it means that 8 plus 8 is 16 squared, that is a positive number anyway. So a positive number can never be equal to a negative number. So we have a contradiction, and therefore this quadratic equation has no solutions at all. So I presented two ways that prove that this quadratic equation has no solutions at all. And therefore the answer to the question is the length of this nine-sided AQ equals to x is equal to 4 units. So we finish with the first question. In the next step, I'll present you the second question, and we will solve the second question of this lecture. In the second question, our task is to find out the area of this quarter circle AOB. So, in the domain, we have quarter circle AOB. This is the small line segment PQ. This is equals to 3 units in its length. This is line segment AQ. This is equals to 4 units in its length. This is angle PQA. That is the right angle. Again, our task is to find out the area of this quarter circle AOB. Okay, so first of all, OA equals to OB. They're both the radii of the quarter circle, and therefore they're equal to each other. if we define the radius of this quarter circle as r, then OA equals to r. This is the radius of the quarter circle is equals to r. According to our definition, and OB is also the radius of the quarter circle, therefore it is equal to r. We have the rule that said that in any triangle, in front of equal sides, there are equal angles. And therefore, in this right triangle AOB, in front of those two equal sides, we have those two angles that must be also equal to each other in their sides. So if you find the side of this angle as x, then the side of this angle must be also equal to x, because of the fact that they are equal to each other according to the rule that I mentioned. We also know that the sum of the angles in any triangle is equal to 180 degrees, and therefore the sum of the angles in this right triangle AOB must be equal to 180 degrees. So which angles we have in the right triangle AOB? We have x plus x, that is 2x, plus 90 degrees, in total must be equal to 180 degrees. So until now, in this right triangle AOB, the sum of the angles must be equal to 180 degrees. That is to say, 2x plus 90 degrees, in total, the sum of those three angles must be equal to 180 degrees. Repeat again, in the right triangle AOB, the sum of the angles is equal to 180 degrees. That is to say, 2x plus 90 degrees in total must be equal to 180 degrees. Here, we will subtract 90 degrees from this equation. And we get that 2x equals to 180 degrees minus 90 degrees in 90 degrees. Here we will divide this equation by 2, and we get that the missing angle x equals to 90 degrees over 2 is 45 degrees. So this is the missing angle x is equals to 45 degrees in size. This is also the missing angle x, it is also equal to 45 degrees in size. In the next step, we will do a construction, that is to say from point O, that is the center of this quarter circle, we will do a perpendicular on BA. Again from point O, we will do a perpendicular on BA. So actually, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We will define the touching point of the perpendicular from point O inside BA. This point is point M. By doing this construction, we're going to do the right small triangle AMO. In the right small triangle AMO, the sum of the angles must be equal to 180 degrees. So which is we have inside the right triangle AMO, we have 45 degrees plus 90 degrees is 125 degrees. 125 degrees plus the size of this third missing angle, in total must be equal to 180 degrees according to the rule that said that the sum of the angles in any triangle is equal to 180 degrees. Therefore, this fourth missing angle must be equal to 45 degrees in size. We also have the rule that says in any triangle, in front of equal angles, there are equal sides. Again, in any triangle, in front of equal angles, there are equal sides. So in this right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other in the length. That is to say, AM equals to MO. So in the right triangle OMA, MA equals to MO. Repeat again, in this right triangle MO, side AM equals to side MO, according to the rule that said that in front of equal angles in this triangle there are equal sides. This is side AM. We'll define the left of right side QM as x. So in total, AM equals to 4 plus x. You can write here that AM or MA equals to 4 plus x or x plus 4. And for this equation, x plus 4 equals to MA equals to MO, we will derive that MO must be also equal to x plus 4 units in its length. This is the missing side OM. It must be also equal to x plus 4 units in its length. In the next step, we will implement the Pythagoras theorem on this right triangle AMO. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So in the right triangle AMO, here by PT is the version from Pythagoras theorem. And again, by PT is the provision for Pythagoras theorem. So in this right triangle AMO, according to the Pythagoras theorem, A square, this is the square of the hypotenuse, equals to AM square plus MO square. And again, in this right triangle AMO, according to the Pythagoras theorem, OA square, that is the square of the hypotenuse, equals to AM square plus MO square. OA is the missing hypotenuse, so we can say that OA is also the radius of this quarter circle. This equals to R. So OA equals to R, therefore OA square is R square. This is the radius of the quarter circle. So A square equals to R square, and it equals to AM square. AM is x plus 4, therefore AM square is x plus 4 square. Plus MO square. MO is also x plus 4, therefore MO square is x plus 4 square. So in total, we should find out that R square equals to x plus 4 square plus x plus 4 square. So R square equals to x plus 4 square plus x plus 4 square is 2 times x plus 4 square. So here we'll take a root out of this equation. And finally get that the square root of R square is R. So the radius of the quarter circle equals to the square root of 2 times the square root of x plus 4 square is x plus 4. So in total, if you want to know that the radius of the quarter circle equals to the square root of 2 times x plus 4 units in its length. This is the radius of this quarter circle. This equals to the square root of 2 times x plus 4 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on this short line segment PQ at point P. Again, we will draw perpendicular on this short line segment PQ at point P. So here, this angle equals to 90 degrees according to our construction. Because we draw perpendicular at PQ at point P. So this angle equals to 90 degrees. In the next step, we will extend the perpendicular OM by straight line until it touches the perpendicular from point P. And we will define the touching point of the extended perpendicular OM with this perpendicular P. This point is point N. OM is a perpendicular, it is absolutely straight line. When you extend a straight line by straight line, the result ON must be also a straight line. So ON is a straight line. If we focus on the lower side of the straight line ON at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of the straight line ON at point M? We have this angle that is the right angle, plus this missing angle. In total, the sum of those angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, it is given us the equation that AB is a straight line. Usually the hypotenuse on the right hand, AOB. So AB is a straight line. So if you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to the sum rule, rule 3. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle, plus this missing angle. Total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in quadrilateral NMQP, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction, and those two angles are both equal to 90 degrees according to rule 3. The sum of 3 angles is of course 270 degrees, so 270 degrees plus the size of this fourth missing angle in total must be equal to 360 degrees according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. So write it down. This is quadrilateral NMQP. And in quadrilateral NMQP, the sum of the angles must be equal to 360 degrees. The sum of 300 degrees is 270 degrees, plus the size of this fourth missing angle, that is the angle P and M. In total, the sum of the four angles must be equal to 360 degrees. Here we'll subtract 270 degrees from this equation. And finally get that the missing angle P and M is equal to 360 degrees minus 270 degrees is 90 degrees. So the fourth missing angle is also a right angle. This is the fourth missing angle, this is also a right angle. And therefore, in quadrilateral NMQP we have 4 right angles, and therefore quadrilateral NMQP is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NMQP, side PQ must be equal to the opposite side NM. But PQ is 3, therefore the opposite side NM must be also equal to 3 units in its length. Likewise, according to the sum rule, in the same rectangle NMQP, side MQ must be equal to the opposite side NP. But MQ is x, therefore the opposite side NP must be also equal to x units in its length. In the next step, we will join points O and P together by straight line. What is the definition of line segment OP? Line segment OP starts from point O, that is the center of the quarter circle, and ends at point P, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, OP is the radius of this quarter circle. This equals to square root of 2 times x plus 4 units in itself. So OP equals to the square root of 2 times x plus 4 units in itself. It is also the radius of this quarter circle. So in the next step, we will implement the Pythagoras theorem on this right triangle O and P. Again, we will implement the Pythagoras theorem on this right triangle O and P. Here by PT, information for Pythagoras theorem. So in this right triangle O and P, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. Again, in this right triangle PNO, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. The hypotenuse PO is also the radius of this quarter circle, that equals to the square root of 2 times x plus 4. Therefore, the hypotenuse square is square root of 2 times x plus 4 square. So in total, OP square is equal to the square root of 2 times x plus 4 square. And it is equal to Pn square. Pn is x, therefore Pn square is x square plus NO square. NO in total equals to OM, that is x plus 4, plus MN, that is 3. So in total, ON equals to x plus 4 plus 3, that is x plus 7. So ON equals to, or NO equals to x plus 7, and therefore NO square equals to x plus 7 square. So in total, we know that square root of 2 times x plus 4 square equals to x square plus x plus 7 square. We will open the brackets on both sides of this equation, and finally get that square root of 2 square is 2 times x plus 4 square. And it is equals to x square plus x plus 7 square. X plus 7 square equals to x square plus 7 square, that is 49, plus 2 times x times 7, that is 14x. So we have here 2 times x plus 4 square. X plus 4 square equals to x square plus 4 square, that is 16, plus 2 times x times 4, that is 8x. and it is equals to x squared plus x squared is 2x squared plus 49 plus 14x. Here we will open the brackets on this side of the equation. We get that 2 times x squared is 2x squared plus 2 times 16 is 32 plus 2 times x squared is 16x, and it equals to 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared get cancelled. After we cancel 2x squared, we left in this side of the equation only with 32 plus 16x equals to 49 plus 14x. So here we will subtract 14x from this equation and get that 32 plus 16x plus 14x is 2x equals to 49. Here we will subtract 32 from this equation and finally get that 2x equals to 49 minus 32 is 17. So 2x equals to 17. Here we will divide this equation by 2 and finally get that x equals to 17 halves. X equals to 17 halves. Actually, this is minus 7 pn equals to x, and x is 17 halves. So this is also minus 7 qm. This also equals to x, and therefore it is equals to 17 halves. Our task is to find out the area of this quarter circle AOB. So what is the area of quarter circle AOB? So what is the area of this quarter circle AOB? Actually, the area of quarter circle AOB equals to pi times the radius of the circle squared over 4. Why? Because of the fact that a quarter circle is 1/4 of a circle. Therefore, we have to divide the area of the circle by 4. So the quarter circle AOB equals to pi over 4 times the radius squared. We only found out that the radius of this quarter circle is also the radius of the circle is equals to the square root of 2 times x plus 4. Again, the radius is square root of 2 times x plus 4, and therefore the radius square must be equal to the square root of 2 times x plus 4 square. So the quarter circle AOB in total equals to pi over 4, and we have square root of 2 square is 2, and we have here also x plus 4 square. Two over 4 is 1/2, so in total this expression equals to pi over 2. So it is pi over 2 times x plus 4 square. That is this quarter circle AOB. So it is pi over 2 times x plus 4 squared. X is 17 halves, so we substitute x by 17 halves plus 4 squared. So the quarter circle AOB in total is equal to pi over 2 plus times 17 halves plus 4. Here we will multiply 4 by 2 and then we divide it by 2 in order to come in front of this number. 4 times 2 is 8. over 2. So we multiply 4 by 2 and then we divide it by 2, so we change nothing. And it is squared. So the quarter second AOB equals to pi over 2. Inside the brackets we have 17 over 8, this is 25 over 2 squared. So it is pi over 2 times 25 over 2 squared. 25 over 2 squared equals to 25 squared, it is 625 over 2 squared, it is 4. So in total, in the numerator of this expression, we have 625 pi over 2 times 4, that is 8. 625 pi over 8 is equal to 245.437 square meters in size. Yet again, I should find out that the area that we are looking for in this question, that is the area of this quarter circle A or B. In total, it is equal to either 625 pi over 8 square meters in size, or in terms of numbers, the area of this quarter circle A or B equals to 245.437 square meters in size. So finish to answer the second question. The next step, I'll summarize the lecture. We'll start with this repetition of the second question. We will repeat on the solution of the first question, and then we repeat on the solution. We will repeat on the solution of the second question. Our task in the first question was to find out the length of this short line 7 cubed is equals to x. We have to find out the value of x. We have to find out the value of x. So in the drawing, we have semicircle APCB. We know that this is angle PQC, this is the right angle. This is 97 QC. This is equals to 6 units in itself. This is called CB. This is equals to 5 units in itself. In addition, we know that arc PA equals to arc CB in its length. And those two arcs are equal to each other and their lengths. And our task is to find out the length of this short line segment AQ that is equal to x. We have to find out the value of x. So this is triangle APB that subtends the diameter of the semicircle, that is AB, and therefore triangle ACB must be equal to 90 degrees in size according to Rule 7 that states that any triangle that subtends on the diameter of the circle or semicircle must be equal to 90 degrees in size. So triangle ACB is a right angle. This is a right angle according to Rule 7. In addition, it is given us the question that arc PA equals to arc CB in its length. And again, according to what is given as the question, arc PA equals to arc CB in its length. Therefore, we can implement here Rule 56. According to Rule 56, if two arcs in a circle or a semicircle are equal to each other in their length, then their corresponding chords must be also equal to each other in their lengths. We join points P and A together by straight line. The corresponding chord of this arc is PA, and the corresponding chord of this arc is CB. According to Rule 56, the corresponding chords are equal to each other. This is to say chord PA equals to chord CB in its length. And again, according to Rule 56, chord PA equals to chord CB in its length. But it is given as a equation that chord CB equals to 5 units in its length, so we can write down here that CB equals to 5, and from this equation 8P PA equals to CB equals to 5, we will have that chord PA must be also equal to 5 units in its length. This is chord PA equals to 5 units in its length. In the next step, we join points P and C together by straight line. By joining points P and C, we get a peritriangle PCA. Peritriangle PCA subtend on chord PA is equal to 5 units in its length. Likewise, we have another peritriangle, that is peritriangle CAB. Peritriangle CAB subtend on chord CB is also equal to 5 units in its length. And because of the fact that those two peritriangles subtend on equal chords, this is to say chord equals to 5, they must be equal to each other in their sizes. That is to say, peritriangle PCA equals to peritriangle CAB according to Rule 57. And again, according to Rule 57, peritriangle ACP equals to peritriangle CAB in its length, in its size, because of the fact that they both subtend on equal chords. So if we define the size of this peritriangle PCA as alpha, then the size of this peritriangle CAB must be also equal to alpha because they are equal to each other according to Rule 57. So in this great right triangle PCQ, this angle equals to alpha according to our definition. This angle equals to 9 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. 1 equals to 90 degrees minus alpha plus alpha is 90 degrees. 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, the right lower triangle ABC, this angle equals to alpha. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha according to the sum that says that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that the right triangle PQC is similar to this right lower triangle ABC according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So we should prove that all the figures of this right triangle PQC are corresponding equal to all the figures of this right lower triangle ABC. And therefore, those two right triangles are similar to each other according to angle similarity rule. So if you then again that we should find out that the right triangle PQC is similar, this is the sign of similar, to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of the green right triangle PQC over side CB of this right lower triangle ABC equals to side QC of the green right triangle PQC over side CA of the right lower triangle ABC. And again, we will derive that side PQ of the green triangle over side CB of the right lower triangle ABC equals to side QC of the green triangle over side AC of the right lower triangle ABC. PQ is the missing side, so limited it is. CB is 5, QC is 6, and AC total equals to x plus 6. Again, AC equals to x plus 6. Is equals to x plus 6. So in total we should find out that PQ over 5 equals to 6 over x plus 6. Here we multiply this equation by 5 and find out that the missing side PQ equals to 5 times 6 is 30, so in total this expression equals to 30 over x plus 6 units in its length. So this is the missing side PQ. This equals to 30 over x plus 6 units in its length. It has given us the question that AC is a straight line. So if we focus on the upper side of the straight line AC at point Q, here the sum of the angles must be equal to 180 degrees according to all three. All three said that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle that is the right angle, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 90 degrees in its size. And therefore, triangle APQ is a right angle. In the next step, we implemented the Pythagoras theorem on this right triangle APQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle APQ, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QH squared. And again, in the right triangle APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QH squared. AP is 5, therefore AP squared is 5 squared, that is 25, and it is equals to PQ squared. PQ is 30 over x plus 6, therefore PQ squared is 30 over x plus 6 squared, plus QA squared. QA is x, therefore QA squared is x squared. So in total, we found out that 25 equals to 30 over x plus 6 squared, plus x squared. So 25 equals to 30 over x plus 6 squared. 30 over x plus 6 squared equals to 30 squared, that is 900 over x plus 6 squared plus x squared. So we have 25 equals to 9 over x plus 900 over x plus 6 squared plus x squared. Here we multiplied x squared by x plus 6 squared, and then we divided by x plus 6 squared in order to have a common factor of this expression. So we have in total 25 equals to 9 over x plus 6 squared, 900 over x plus 6 squared, and we multiplied x squared by x plus 6 squared, then we divided by x plus 6 squared, so we change nothing. So in total we found out that 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. Here we multiplied this equation by x plus 6 squared, and finally found out that 25 times x plus 6 squared. Here x plus 6 squared you can cancel, and we have only 900 plus x squared times x plus 6 squared. So in total we found out that 25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared. So we have here 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared plus 2 times x times 6, that is 12x. On the other side of the equation we have 900 plus x squared times x plus 6 squared. Again, x plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. We open the brackets on this side of this equation, and finally found out that 25 times x squared equals to 25x squared. 25 plus 25 times 36 is 900, and 25 times 12x equals to 300x. On the other side of the equation, we have 900. Here we have x squared times x squared plus 36 times 12x. So we open the brackets of this expression, and we found out that x squared times x squared is x to the power of 4. And we have x squared times 36 is 36x squared. And we have also x squared times 12x equals to 12x cubed. Here we have 900 on both sides of this equation, so 900 we get cancelled, and we cancel 900. In this side of the equation we left only with 25x squared plus 300x, while in the other side of the equation we left with x to the power of 4 plus 12x cubed plus 36x squared. So here we subtract 25x squared from this equation. So in this side of the equation we left with only 300x, while on the other side of the equation we have x to the power of 4 plus 12x cubed, and 36x squared minus 25x squared is 11x squared. So total we found out that 300x equals to x to the power of 4 plus 12x cubed plus 11x squared. Here we subtracted 300x from this equation. Therefore, on this side of the equation we left with nothing, that is to say 0, and on the other side of the equation we have x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. I copied this equation again in the new page. So if you found out that x to the power 4 plus 12x cubed plus 11x squared and square that x equals to 0. So here we took out x as second factor from those four expressions, so inside the brackets we left with x cubed plus 12x squared plus 11x minus 300 equals to 0. This equation has two possible solutions. The first solution for this equation is x equals to 0. Then 0 times anything is 0. You get that the left side of the equation equals to the right side of the equation. That is to say 0 equals to 0. So the first solution to this equation is x equals to 0. The other solution to this equation, the second solution, is that if the expression inside the brackets equals to 0, then 0 times x is 0. You get that 0 equals to 0. So the second solution to this equation is that this expression equals to 0. That is to say, x cubed plus 12x squared plus 11x minus 300 equals to 0. But the problem is that x can never be equal to 0. So the first solution to this equation is the incorrect solution. Why? Because x is the length of line segment AQ, so x as a length, it must be a positive number. Again, x is the length of line segment AQ, so x as a length, it must be a positive number. 0 is definitely not a positive number, and therefore this solution is the incorrect solution. So x must be equal to a positive number. The second solution to this equation is this expression equals to 0. That is to say, x cubed plus 12x squared plus 11x minus 300 equals to 0. First of all, we check if x equals to 3 solves this equation. That is to say, we just substitute x by 3. So x cubed is 3 cubed, that is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9, and 9 times 12 is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, plus 300 equals to 0. 27 plus 108 plus 33 is 168, plus 300 equals to 0. 168 plus 300 is definitely not equal to 0. So x equals to 3 doesn't solve this equation. That is 3, x is not equal to 3 in this equation. In the next step, we check if x equals to 4 solve this equation. That is to say, we just substitute x by 4. So x cubed is 4 cubed, that is 4 times 4 times 4 is 64, plus 2x squared. X is 4, so x squared is 4 squared, that is 16, and 16 times 12 is 192, plus 11x. X is 4, so 11x is 11 times 4, that is 44, plus 300, it should be equal to 0. 64 plus 44 is 108, plus 192, plus 300 equals to 0. 108 plus 192 is 300, and 300 plus 300 indeed equals to 0. So x equals to 4, solve this equation. Okay. And therefore, we can present, because of the fact that x equals to 4 solve this equation, we can present this equation in a different way. So we actually found out that x cubed plus 12x squared plus 7x plus 300 equals to 0. This expression is identical to this expression. That is to say, this expression in total equals to x times 4 times x squared plus 16x plus 75. That is to say, if you open the brackets of this expression, you get that those two expressions are identical. But this expression equals to 0, therefore the identical expression must be also equal to 0. So now it is very easy to solve this equation. Why? Because here we have two solutions that are possible to this equation. Either x times 4 equals to 0, and then 0 times anything is 0. So the first solution to this equation is x times 4 equals to 0. And the second solution to this equation is that the expression inside this bracket is 0. And 0 times x times 4 is 0. And we get that 0 equals to 0. So the second solution to this equation is that x squared plus 16x plus 75 equals to 0, and then 0 times x minus 4 equals to 0. So the first solution to this equation is x minus 4 equals to 0. Here we added 4 to this equation, and I found out that x equals to 4. So the first solution to this question is that aq equals to x is equal to 4 units. Now we have to check whether if the second solution is also a true solution. That is to say, we have to check if this quadratic equation can be equal to 0. That is to say, we have to check if x squared plus 16x plus 75 would be equal to 0. So actually this is the quadratic equation, and the general formula for the quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. The expression inside the root is b squared minus 4 times a times c. That is the determinant of this general quadratic equation. Repeat again, b squared minus 4 times a times c is defined as a determinant of this quadratic equation. And we know that if the determinant of any quadratic equation is negative, then the quadratic equation has no solution at all. So we must verify that our specific the determinant of our specific quadratic equation is not a negative number. Because if it is a negative number, it means that our specific quadratic equation has no solutions at all. So this is our specific quadratic equation, x squared plus 16x plus 75 equals to 0. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. The determinant of any quadratic equation is b squared minus 4 times a times c. So we just have to put the numbers inside this determinant in order to find out whether if the determinant of our specific quadratic equation is negative or not. B is 16, therefore b squared is 16 squared, it is 256, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is 75, and therefore minus 4 times 75 is minus 300. So in total, if you found out that the determinant of our specific quadratic equation is equals to 256 minus 300. 256 minus 300 is definitely a negative number. And because of the fact that the determinant of our specific quadratic equation is a negative number, it means that our specific quadratic equation has no solutions at all. And therefore, the second solution to this equation is an incorrect solution. Why? Because x squared plus 16x plus 75 can never be equal to 0. Therefore, we cancel the solution, and we're left only with the first solution for this equation, that is x equals to 4. So if you found out that the length of line side EQ is equal to x is equal to 4 units in its length. In the next step, I present to you another way to present to you another proof that this quadratic equation is incorrect quadratic equation. That is to say, it has no solutions at all. Again, our specific quadratic equation is x squared plus 16x plus 75 equals to 0. Here we just substitute 75 plus 60 by 64 plus 11. So this quadratic equation in total equals to x squared plus 16x plus 64 plus 11 equals to 0. This expression x squared plus 16x plus 64 in total is equal to x plus 8 squared plus 11 equals to 0. Here we subtracted 11 from this equation and found out that x plus x squared equals to minus 11. Minus 11 is a negative number, while x plus 8 squared is a positive number. And a negative number can never be equal to a positive number. Due to the contradiction here, we must conclude that this solution is a correct solution. That is to say, x squared plus 16x plus 75 can never be equal to 0. So we can say the second solution for two reasons. And we left only for the only solution to this question, that is actually line squared aq is equal to x is equal to 4 units in its length. So we finish to repeat on the first question. In the next step, I repeat on the solution of the second question. In the second question, our task was to find out the area of this quarter circle AOB. So in the drawing we have quarter circle AOB. This is the short line element PQ. That is equals to 4 units in itself. This is line segment AQ. That is equals to 4 units in itself. This is angle PQ8. This is the right angle. Again, our task is to find out the area of this quarter circle AOB. This angle in the right angle is in any quarter circle. So OB equals to OA, they're both the area of the quarter circle and therefore they are equal to each other. So we define the radius of this quarter circle as R, therefore OA is the radius and OB is also the radius, so both equal to R. We have the rule that says that in front of equal size in the triangle there are equal angles. So in the right triangle AOB, in front of those two equal sides, we have those two angles that must be also equal to each other in their sizes. So if you define the size of this angle as x, then the size of this angle must be also equal to x because they are equal to each other according to the rule that I mentioned. We have the rule that said that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle AOB, x plus x, that is 2x plus 90 degrees, in total must be equal to 180 degrees. And again, in the right triangle AOB, x plus x is 2x plus 90 degrees, in total the sum those three angles must be equal to 180 degrees. Here we subtract the 90 degrees from this equation. If we found out that 2x equals to 180 degrees minus 90 degrees is 90 degrees. If we divided this equation by 2, if we found out that the missing angle x equals to 90 degrees over 2, that is 45 degrees. Those two angles are both equal to x and x equals to 45 degrees in its size. In the next step, we did the construction, this is to say from point O, that is the center of this quarter circle, we do perpendicular on BA. Again from point O, we do perpendicular on BA. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and side BA, this point is point M. By doing this construction, we get the right triangle AMO. Inside the right triangle AMO, in the right triangle AMO, the sum of the rest must be equal to 180 degrees. So 45 degrees plus 90 degrees is 135 degrees. 135 degrees plus the size of this third missing angle, in total must be equal to 180 degrees. Therefore, this third missing angle must be equal to 45 degrees in size. So, but again, in the right triangle OMA, in front of equal angles, we have those two sides that must be also equal to each other, according to the rule that in a triangle, in front of equal angles, we have equal sides. So in the right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other in their lengths. That is to say, AM equals to MO. In the right triangle AMO, according to the rule that I mentioned, AM equals to MO. We define the length of line QM as x, and therefore AM in total equals to 4 plus x. Again, if we found out that AM in total equals to x plus 4, and from this equation x plus 4 equals to AM equals to MO, we will derive that MO must be also equal to x plus 4 units in itself. And again, this is the missing sign MO is equal to x plus 4 units in itself. In the next step, we implemented the Pythagoras theorem on this right triangle MO. This right triangle MO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to AM squared plus MO squared. The hypotenuse AO is also the radius of the quarter circle. This is equals to R. So in the right triangle AMO, according to the Pythagoras theorem, OA squared, that is the square of the hypotenuse, equals to AM squared plus MO squared. OA is the radius of this quarter circle that is R, therefore OA squared is R squared, and it equals to AM squared. AM is x plus 4, therefore M squared is x plus 4 squared. Plus MO squared. MO is also x plus 4, therefore MO squared is x plus 4 squared. So in total, we found out that R squared equals to x plus 4 squared plus x plus 4 squared. So R squared equals to 2 times x plus 4 squared. Here we took out of this equation, we found out that the radius R of this quarter circle equals to the square root of 2 and times the square root of x plus 4 squared is x plus 4. So in total, the radius R of this quarter circle equals to the square root of 2 times x plus 4 units in itself. In the next step, we did another construction, that is to say, this is the short line segment PQ, so we do perpendicular on the short line segment PQ at point P. So this angle equals to 90 degrees according to our construction. And then we extended the perpendicular OM by straight line until it touches the perpendicular from point P. We define the touching point of the extended perpendicular OM with the perpendicular from point P. This point is point N. It is given us the equation that AB is a straight line. So if you focus on the upper side of the straight line AB at point Q, here the sum of the areas must be equal to 180 degrees according to Rule 3. Rule 3 says that the sum of the areas on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle plus this missing angle, so that the sum of those angles must be equal to 180 degrees. And therefore this missing angle must be equal to 90 degrees in its size. Likewise, OM as a perpendicular, it is definitely a straight line. When you extend a straight line by straight line, the result ON is also a straight line. So ON is a straight line. If you focus on the lower side of the straight line ON at point M, here the sum of the areas must be equal to 180 degrees according to the sum rule, all three. So which angles we have at the lower side of the straight line ON at point M? We have this angle that is the right angle, plus this missing angle, so that the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in total, if on the other NPQM, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction. Those two angles are also right angles according to all three. The sum of three angles is of course 270 degrees, so 270 degrees plus the size of this fourth missing angle, this is the angle PNM, in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. But again, in quadrilateral NMQP, the sum of the angles must be equal to 360 degrees. That is to say, 270 degrees plus the size of the fourth missing angle, that is the angle PNM, total must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we found out that the missing angle PNM equals to 360 degrees minus 470 degrees is 90 degrees. So this fourth angle is also a right angle. Therefore, quadrilateral NMQP is 4 right angles. Therefore, we can relate to quadrilateral NMQP is a right angle. But we also know that the opposite sides of left angle are equal to each other. So left angle NMQP, side PQ must be equal to the opposite side NM. But PQ is 3, therefore the opposite side NM must be also equal to 3 in its length. Likewise, according to the same rule, the same left angle NMQP, side MQ must be equal to the opposite side NP. But MQ is x, therefore the opposite side NP must be also equal to x units in its length. In the next step, we join point O and P together by side line. Point O is the center of this quarter circle. Point P is the point of the quarter circle itself. This is exactly the definition of radius. Therefore, OP is the radius of the quarter circle. This is equal to the square root of 2 times x plus 4. In the next step, we implement the Pythagoras theorem on this right hand triangle PNO. This right hand triangle PNO, according to the Pythagoras theorem, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. Again, in the right triangle OMP, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. PO is the radius of the quarter circle, that is equals to the square root of 2 times x plus 4, and therefore PO squared is the square root of 2 times x plus 4 squared. And it equals to Pn squared. Pn is x, therefore Pn squared is x squared, plus NO squared. NO in total equals to x plus 4 plus 3, that is x plus 7, and therefore NO squared equals to x plus 7 squared. So in total, we should find out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. Here, open the brackets of this expression. We have square root of 2 times square root of 2 squared is 2, and times x plus 4 squared. And it equals to x squared, and x plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. So here we have 2 times x plus 4 squared. X plus 4 squared equals to x squared, plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. On the other side of this equation, we have x squared plus x squared is 2x squared, plus 49, plus 14x. Here we open the brackets of this expression, and here we have 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times 8x is 16x, equals to 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared we can cancel, so after we cancel 2x squared, on this side of the equation we left only 32 plus 16x, while on the other side of the equation we left with 49 plus 14x. Here we subtract the 14x from this equation, so in this side of the equation we have 32, and 16x plus 14x is 2x, and it is equal to 49. So 32 plus 2x equals to 49. Here we subtract 32 from this equation, and finally found out that 2x equals to 49 minus 32 is 17. So 2x equals to 17. Here we divided the equation by 2. We divided this equation by 2, and finally found out that x equals to 17 amps. Okay, our task is to find out the area of this quarter circle. The area of any quarter circle equals to pi times the radius of the circle squared over 4. Why? Because the quarter circle is 1/4 of a circle. Therefore, we have to divide the area of the circle, that is pi times the radius of the circle squared, by 4. So the area of quarter circle A or B equals to pi over 4 times the radius of the quarter circle, or the radius of the circle squared. The radius of the quarter circle squared equals to the square root of 2 times the radius of the quarter circle equals to the square root of 2 times x plus 4, and therefore the radius squared equals to the square root of 2 times x plus 4 squared. So we have pi over 4. We open the brackets of this expression. Square root of 2 squared is 2 times x plus 4 squared. 2 over 4 is 1/2, so in total this expression equals to pi over 2 times x plus 4 squared. We just now found out that x equals to 17 amps. So we can cancel x by 17 amps. So we have here pi over 2 times x plus 4 squared. So it is pi over 2 and x is 17 half plus 4 squared. So it is pi over 2 times 17 halves plus 4. Here we multiply 4 by 2 and then we divide it by 4. We multiply 4 by 2 and then we divide it by 2 in order to have a factor with this number. So 4 times 2 is 8 over 2. We multiply 4 by 2 and then we divide it by 2, so it is nothing. So in total we found out that the quarter second will be equals to pi over 2 times 17 over 8 over pi over 2 times 17 plus 8 over 2 squared. 17 plus 8 is 25, so in total this expression equals to pi over 2 times 25 over 2 squared. So it is pi over 2 and times 25 over 2 squared. 25 over 2 squared equals to 25 squared, that is 625 over 2 squared, that is 4. So in total the quarter second will be equals to 625 over 4 times 2, that is 8. So in total, they have this quarter second, that is that we're looking for in this question. This equals to either 625 pi over 8 coordinates in size. In terms of numbers, the area of this quarter second will be equals to 245.437 coordinates in size. Okay, thank you very much.